We're now going to take a look at what are called common factors, but more specifically common factors for polynomials. But before we do that, let's take a look at expanding a quadratic which is in factored form. If we want to expand the following quadratic, one way is to take the 4x minus 1 and multiply it by both terms within the second bracket. If we do that, we're saying we have 4x minus 1 times 2x, or if we like 2x times 4x minus 1, and then 4x minus 1 times 3. So 3 times 4x minus 1. Next step is to distribute again. So take the 2x times the 4x, the 2x times the minus 1, the 3 times the 4x, and then the 3 times the minus 1. So what we have now is 8x squared minus 2x plus 12x minus 3. And if we collect our like terms, we get 8x squared plus 10x minus 3. So our goal within the next few videos is to be able to take an expression that's in standard form and get it all the way back into factored form. So recall that this is called our factored form. Great if we want to find zeros, our axis symmetry, optimal value, and vertex. And this is called our standard form. We've already learned how to go from factored form to standard form. So our goal in the next few videos is to go the other way. So before we do that, let's take a look at what are called common factors. So looking at this example, we are going to factor the expression 2x squared plus 4x. So what we're going to look for is the greatest common factor in both the terms we have here. So the 2x squared and the 4x. What are they both divisible by? I see that the 2 and the 4 are both divisible by 2. That's the greatest common factor. And the x squared and the x, well, they're both divisible by x. So what you're looking for is the greatest common factor between the two numbers, and then looking for the greatest variable or the highest degree on a variable that you can remove from both those terms. And then what we're left with is the remaining factor. So what sometimes people like to think about is, well, now I'm going to take that 2x squared and divide it by the 2x that I factored out and do the same thing with the 4x. So 2x squared divided by 2x, the 2's will become 1. 2 divided by 2 is 1. And x squared divided by x leaves you with an x. In the second term, 4x, 4x divided by 2x, so start with the numbers. 4 divided by 2 is 2. And x divided by x is 1. So we're just left with x plus 2. We can always go back and check our work. So we have 2x, x plus 2. If I expand this expression, that's 2x squared plus 4x, which is what we started with. So here is the factored form for our expression. Let's take a look at the next one. What is the greatest common factor in both these terms? So starting with the number, we see that both 3 and 9, the greatest common factor is 3. In both terms we have an x. So we see in the first term we have an exponent of 2 on x, and then we see in the second term we have an exponent of 1 on x. So that means we can divide both of these by x. And similarly, we see we have a y in the first term, a y squared in the second, so they're both divisible by y. If we think about division, so we're going to divide these both by 3xy. 3 divided by 3 is 1. X squared divided by x leaves me with an x, and y divided by y is 1, so we're just left with x. 9 divided by 3 is 3, so we have minus 3. X divided by x is 1, and y squared divided by y is y. So we end up with 3xy times x minus 3y. Again, if you want to expand that, you'll get back to the original equation. Let's look at the next one. And for practice, we're always going to assume that if you see a negative leading coefficient on the first term, we're going to factor out a negative number. So what are both those terms divisible by? Well, they're both divisible by 4, but since our first term has a negative number, we're going to factor out the negative 4 from both those terms. Now we look at the x's, or the variables. We see an exponent of 5 on the first, an exponent of 3 on the second. So that means we're going to take out the lowest exponent, so we're going to take out the x cubed from both. What do we have left? Well, let's divide both of these by 4, or negative 4x cubed, sorry. Negative 8 divided by negative 4. Well, that's a 2. X to the power of 5 divided by x cubed, that's x squared. And 4 divided by negative 4 is minus 1, and x cubed divided by x cubed is 1. So we get 2x squared minus 1 for our second factor, or bracket. Let's try one more. What do they both share in common? Well, we have 4xy and 3y. The only common factor for 4 and 3 is 1. We're not going to worry about that. There's an x in the first term, but not the second. But they do have both a factor of y. So we're going to take out that y. If we divide them both by y, I get 4x for the first term. And 3y divided by y gives me 3. So there is the last expression factored. This last one is important because it's going to help us with the next example. So if we look at this example, this is exactly the same as above. We had 4xy plus 3y. And this time, instead of having a y here and here, we have a 3x minus 7. So what we are saying is that we have 4x times 3x minus 7 plus 3 times 3x minus 7. So our common factor is 3x minus 7. If we divide out that common factor, we're left with 4x plus 3. So you notice from above, we had y times 4x plus 3. But in this one, it's just 3x minus 7 times 4x plus 3. So our common factors don't have to be just a single variable or a number. They can be expressions. So let's go to the next one. We're saying 2 times 2x minus 3 minus x times 2x minus 3. Notice both of those terms are being multiplied by 2x minus 3. That's what we call our common factor. What we're left with is, if we get rid of those, because we've factored them out, we have 2 minus x. And there's the factored form for that expression. Let's try it again. So we see that we have 2y times x minus 4, and this time we have negative 1 times x minus 4. So if we take out our common factor of x minus 4, we're left with 2y minus 1, and we're done. Gone and gone, 2y and minus 1. And finally, the last one, which has a small trick, we see the 2x minus 7, but over here, this is not 2x minus 7, so we cannot common factor the way it is. However, we can make a small adjustment. If you think about negative 2x plus 7, that's the same thing as saying negative 1 times 2x minus 7. How do I know that? Because I can use my distributive property, and negative 1 times 2x is negative 2x. Negative 1 times negative 7 is plus 7. So we see that the left side is equal to the right side, that this is equal to this. So what I'm going to do here is rewrite this expression. So I have 2x times 2x minus 7, and then I said that this is the same as this, so that's minus 1 times 2x minus 7. So if we look at this closely, we have 2x times 2x minus 7 and negative 1 times 2x minus 7. So our common factor is 2x minus 7, and what we're left with is 2x minus 1. So there's the factored form for that expression. So why is this important? Well, looking at these here, we've sort of seen these already. So let's go back to the top. Notice what we have here is 2x times 4x minus 1 and 3 times 4x minus 1. Now that we know how to factor this, we can go in reverse order and get back to this form here. Remember, our goal is to go from standard form to factored form, to start here and get all the way back up to the top. So we've done one of the steps. We've looked at going from this step up to this step. And again, we see we have 4x minus 1, 4x minus 1. So we took that factor out, and we're left with 2x plus 3. We're also going to look at this step next, how to go from here to here. And in the next video, we'll learn how to go right from standard form all the way up to factored form. All right, so let's go back and take a look. The next important thing we need to look at is called factoring by grouping. And that's exactly what it sounds like. We're going to factor groups. So we're going to take this group here, factor it, and this group here and factor it, and see what happens. So let's start with the first group, 3x squared plus 2x. What is common between 3x squared plus 2x? Well, they both have a factor of x. What's left over if we divide by x? We have 3x plus 2. So this is the same as this, just in its factored form. Let's try the next one. 6x plus 4. So what do they have in common? Well, they're both divisible by 2. So I'm going to factor out the 2. Don't forget the plus sign. And I'm left with 3x plus 2. If I've done everything right, we notice that both these terms have a 3x plus 2. So I can factor out the 3x plus 2. And I'm left with, if I take those out, x plus 2. Notice we've now got the factored form of a quadratic. And again, let's go to the top. That's going from this step here, going through that step to get to factored form. So we've taken 4 terms, brought them down to 2, and then common factored. All right, let's try this a few more times. So example B, what do they share in common? So let's start with the first two. The first two are divisible by 7x. What's left over? An x minus 3. Now let's take a look at the next two. Remember what I said, if you see a leading term that's negative, well, I'm going to take out a negative 1 from both of those. And again, that leaves me with x minus 3. If we look at both these expressions, they both have x minus 3. If I take out the x minus 3, I'm left with 7x minus 1. And there is my factored form for that quadratic. C. Let's look at this one. I have 2xy plus y. My common factor here is y. So it leaves me with 2x plus 1. Y divided by y is 1. Again, I see a negative start, or negative leading coefficient in the next two terms. So this time I'm going to take out a negative x. 2x squared divided by x is just going to give me a 2x. And an x divided by x, and since I'm taking out a negative, is going to give me plus 1. Right? Negative x divided by negative x equals 1. Negative 2 divided by negative 2 equals 1. Same concept. We've done this right because notice we have a 2x plus 1 in both expressions. So we get 2x plus 1, and then what's left over is y minus x, and we're done. Last example, and we're going to see why factoring is now important. We have y equals 20x minus 5x squared. I want to find the coordinates of the vertex for this parabola. So I need to find the zeros, the axis symmetry, optimal value, and then I'll have the vertex. We can create a table of values and try to find the vertex, but let's see if we can do it algebraically without a table of values. So remember, the first step to find a vertex is to look for the zeros. And the zeros are where y equals 0. So we're going to start with this. 0 equals 20x minus 5x squared. This is in standard form. In order to find the zeros, we need to get it into factored form. So now we are going to factor. So for this expression, we see there's a common factor of 5x. If we take out the 5x from 20x, we end up with 4. And if we take out the 5x from 5x squared, we end up with negative 1x, or just minus x. Now that it's in factored form, we can find the zeros. So we're going to take each of these factors and state when they are equal to 0. So we can see for the first one, I want to know when 5x equals 0. Well, that's true if I divide both sides by 5. When x is equal to 0, 0 divided by 5 is 0. And for the second one, 4 minus x, I want to know when that equals 0. So that'll give me negative x equals negative 4. And therefore, our second 0 is at positive 4. And for some of you, you can see it right from the equation, and you can tell me that x1 is 0 and x2 is 4. Now that I have the zeros, I can determine the axis of symmetry. Remember, the axis of symmetry is just the average of the two zeros. So we have 0 plus 4 divided by 2, which tells us our axis of symmetry is equal to 2. Once we have the axis of symmetry, we can find the optimal value. And to find the optimal value, we sub in the axis of symmetry into our equation, y equals 20x minus 4x squared. And what we get is y equals 20 times 2 minus 4 times 2 squared, which equals 40 minus 16, which equals 24. So therefore, our vertex is axis symmetry of 2, optimal value of 24. The next part is if we want to sketch a graph, we now have the two zeros and we have the vertex. So going back up to our grid, we can put in the two zeros. We know one's at 0, 0, so that's the one y-intercept. The next one is at 4 and 0, that's the second y-intercept. And the vertex is at 2 and 24. And we see that this parabola opens down, which is great because we see that in our expression, our a value is negative, and therefore the parabola should open downwards.